So when you were in geometry, you got to see a normal trapezoid. And let me draw a normal trapezoid for you guys. And okay, I suck at art, remember guys, so give me a break there. I'm sure maybe I have it in my shapes here, but I'm not gonna bother. And that's base 1, and that's base 2, and then they told you the perpendicular height is your height. And the area for that trapezoid is height, base 1 plus base 2, all that divided by 2. Your trapezoids that you're gonna see in calculus are gonna look like this. It's still the same formula. It's still base 1, it's still base 2, that is still a height. And the formula for that area is still the same, HB1 plus B2 divided by 2. And then maybe you're thinking, Chavez, how are they the same? I see a triangle over here. Well, yeah, guys, but look, this is being deleted, and so is this, and I just have this. So your B2 is actually shorter on this triangle, so it equates to the same deal. If you don't believe me, try it out. Grab some normal trapezoid. Now, of course, this trapezoid, if I extend it, it's going to have that little extra triangle. So yes, it has more area. But this is still a trapezoid, and we can still use that formula for that trapezoid. If you don't like it, relax. You can always break it up into a rectangle and a triangle, and find the area of that rectangle, and then find the area of the triangle, and add them up. It's going to be the same, guys. Trust me. It's going to be the same. Okay. Are we okay with that? All right, next, there is a formula, as you are probably looking at it. Don't even bother with this one down here. Erase it, delete it from your memory. There is a formula, and you know me, I like to show where those formulas come from. So I'm going to show that, because I don't want you to just look at it and be like, I'm going to use this formula. Matter of fact, you probably won't even need that formula, because it's very rare, like I said. I haven't seen many problems on the AP exam that give you equal heights. Remember how our height's going to look for a trapezoid. So let me draw for now a graph. Just some random graph, some random graphy boy. And okay, let me see. I'm going to say, here's my first trapezoid. See, that's a trapezoid there, guys, where the bases are vertical. And the height is going to be this guy. And then here's a second trapezoid, trapezoid 1, trapezoid 2. And then here's a third trapezoid. And here's a fourth trapezoid. And let's give coordinates. So I'm going to say that's x naught. So that means this coordinate way up here is x naught comma y naught. And let's see, x1, x2, x3, x4. So this coordinate way up here is x4 comma y4. Have I confused anyone? All right, all of these heights, quote unquote. Now remember, my trapezoid looks like this. So I'm going to draw here on the side. Side note. My trapezoid is looking like this, where this is my height, and this, quote unquote, is your base. Base 1 and base 2. So, according to my area formula of a trapezoid, I'm talking about this one, all of these have equal h's. My first trapezoid, so the first term that you see is my first trapezoid. Height 1, base 1 is dictated by this x value, well, the y value, right? The vertical distance. So the vertical distance, this, I guess, let me highlight it in green, guys. This vertical distance in green is base 1, and that is determined by that y value. So y naught plus, here, that green line there is your base 2 of trapezoid 1, y1, close it. And I'm dividing that dude by 2, because that's the area of a trapezoid. Have I lost anyone, guys? Plus h, parenthesis. Now for trapezoid 2, it's this, the green line, the second green line, which is the first base of trapezoid 2. So that's going to be y1 plus y2 divided by 2. Does everyone see where I got that? No? Okay. This coordinate way up here is x1 comma y1. And this coordinate here is x2 comma y2. So y1 is the value of my first base, and y2 is the value of the second base. Plus h parentheses, the third one, it's going to be y2 plus y3 over 2. Plus finally for the fourth one is going to be h times y3 plus y4 over 2. I want you to notice that I can factor out an h over 2. I'm still doing the same one, guys. And now look what I have. Y naught plus y1 plus y1 plus y2 plus y2 plus y3 plus y3 plus y4. I factored out the h over 2, guys. All of them have h over 2, h over 2, h over 2. And I want you guys to see, look at this. Look how awesome this is. Besides my first and last coordinate, I have two y1s, I have two y2s, I have two y3s. So my final formula for area of a trapezoid is h over 2 in parentheses y naught plus 2y1 plus 2y2 plus 2y3 plus y4. And there it is, guys. We just derived this formula right here. Isn't that cool? Y naught is your first point, yn is your last coordinate, the yn minus 1 is your second to last coordinate. So if you have 4 trapezoids, you need 5 points. So however many trapezoids you need 1 extra point. If you want 3 trapezoids, you need 4 points. Quote unquote. 4 y values. How do we feel, guys? Do we feel okay? Awesome. I saw 1 thumbs up and everyone else was just like, whatever. Thank you, guys. You guys make me laugh. But I hope that you're happy and I hope that we are learning. All right, example 1. It says, use the trapezoidal rule with n equals 4. So this means that I want 4 rectangles to estimate the area under the curve. This means area under the curve of x squared from 1 to 2. Compare the estimate with the exact value. Oh man, have we talked about how to do the exact value? We have not. That is a shame. Okay, delete, compare the estimate with the exact value. Delete that. We have not talked about how to get the exact value, have we? I mean, we've talked about how to do area, like how to get an infinite amount of rectangles, but we haven't talked about how to get the exact value. Darn it, I didn't catch that. So delete that line. We're just gonna estimate. We'll come back to it later. So here we go, guys. I am exaggerating x squared. Here's x squared, exaggerated. From 1 to 2. So I'm gonna say 1's right here, and I'm gonna say 2 is right there. They want 4 rectangles. So let's see, 2, 2, 2. There it is. They're all gonna be, because I have 4 rectangles, guys, let's see, my change in x is gonna be 2 minus 1 divided by 4, so that's gonna be 1/4. You guys didn't need to do that. You can probably figure it out just by looking at it. So here we go. Here's my first trapezoid. Connect those points. Point there, second trapezoid, third trapezoid, fourth trapezoid. If you were to zoom in on the trapezoids, they are just barely slightly above the curve, just barely. Maybe we'll tell you how to do the exact in a little bit. We'll see. All right, because the heights are the same, I can use my formula. So I'm gonna use this formula here. And I'm gonna say my area is, let's see, what's the height of each trapezoid? 1/4. 1/4, and I'm gonna divide that by 2. So in a little bit, I'll write that as 1/8. And it's the first y value up here. That y value is dictated by the function x squared. So it's gonna be 1. squared plus, and it tells me to do 2 times y1. So I'm going to go 2 times the next one happens at 1.25, and I square it. Does everyone know why I'm squaring it? Because the function is x squared. I need to know that height. Plus 2 times 1.5 squared plus 2 times 1.75 squared plus, do I continue writing 2? No, it's the last coordinate. The last coordinate, you just write whatever the x function is or whatever the function is and square that dude. I'm squaring it because the function is x squared. There it is. I take my calculator. So this is going to turn to 1/8 times whatever all that is. So I'm going to find out what that is. I'm going to use my calculator here. 1 plus 2 times 1.25 squared plus 2 times 1.5 squared plus 2 times 1.75 squared plus 2 squared, which is 4. I got 18.75, and I still have to divide that by 8. I got 2.34375. On the AP exam, if you have this question, you just needed to write it to the first 3 digits after the decimal, but 0.75 is exact, well, for the number of rectangles that we have. So I just wrote them all. Okay. I'm kind of tempted to give you guys how to find the exact value, but I need you guys to vote. Do you guys want to see how to do it really fast? Or do you want me to have a lesson on how to find the exact area? Like a real lesson. Thumbs up if you just want to see it really quick, like how to find the area, or just, okay, so I see 2 thumbs, 3. Okay, all right, here's how you do it, guys. And I should be having, this is called a definite integral. So the first job we got to do is, I'm finding the exact area. Here's how you find the exact. How to find exact. And we're kind of cheating. We're kind of going like skipping a whole lesson on this, but we're going to find it. First, do the antiderivative of x squared. Does everyone know how to do antiderivative? It's x cubed over 3. Now remember, we used to say plus c. But because we have limits, you're not going to write plus c. You're going to do this. X cubed over 3 is the antiderivative. Put it in a bracket. Put a 1 in the bottom and a 2 at the top. So that means that we are going to evaluate x cubed over 3 from 1 to 2. And you're always going to do upper minus lower. So I'm going to put equals. Well, I don't have enough room to put an equals there, so I'm just going to put it in the bottom here. Equals. I'm going to plug in a 2. So here it is. 2 cubed over 3, close it, minus, so it's upper minus lower. Open it again, and and now I'm going to plug in a 1. 1 cubed over 3. Now we need to have a whole lesson, but there it is pretty much. We will talk about why it works later on. So 2 to the 3rd power is 8, so 8 over 3, minus 1 to the 3rd power is 1, so 1 over 3. 8 minus 1 is 7 over 3. This is the exact area. Exact area. Don't worry, we will have a lesson on this. YouTube, don't give me a thumbs down for this. Don't worry, my class will get the theoretical reasoning for why this is. So how close is 7/3 to 2.34? Pretty close, guys. Let's see, 3, 6. This is 2.33333 forever. And look at that. Are we shocked that it's an overestimate? No, we're not shocked, because if you zoom in on the trapezoid, you can see a little piece of that trapezoid above the curve. And all of them are going to be a little piece. I didn't do a good job of drawing, but all of them are going to be slightly above the curve. All right, guys, I think we're good now. All right. Next time I'll see if I can do a lesson on how to find exact, but we're still doing approximation. All right, on the interval -2 to 4, if 3 equal subdivisions are used equal, what is the trapezoid approximation for area under this curve? It would be nice if you guys knew how that curve looked. You do not need to know exactly how the curve looked. It would be nice though. E over x divided by 2 looks something like this. -2 somewhere over here. 4 is, let's see, that's 2, 2, 4. I don't know, somewhere right here. My trapezoids are all messed up. It's okay, guys. They want 3 trapezoids. Here's my first trapezoid. Trapezoid 1. Here's my second trapezoid. Trapezoid 2. And here's your third trapezoid. I can use my formula. Hopefully you can look at it and know what the height is. Here's the height of each trapezoid there. The height is 2. If you don't know that, no big deal. Just do delta x equals b minus a. So change in x. That's your height. Change in x is 4 minus a -2 divided by 3, so you get 2. So here's my formula. Area equals, and I'm going to go back to red, guys. 2 divided by 2. This is my height. They're all the same. And that 2 is part of the formula. Part of formula. And then my first y value, you do not put a 2 on it. That's going to be e to the -2 over 2. That's because the y value is determined by your function, guys. Plus 2 times e to the 0 over 2 plus 2 times e to the 2 over 2 plus, and then my last point, you do not put a 2 in the front, e to the 4 over 2. I'm tempted to delete the 2's, guys. I like you guys, I'm tempted to like the 2 on the top, 2 on the bottom, 2 on the top, 2 on the bottom, cancel them out. But I'm not, because I noticed that none of these answer choices have a 2 in the bottom. And if I were to cancel them out, I would have a 2 in the bottom here and here. So I'm going to factor out the halves, the 2's in the bottom. So here I am factoring out the halves. That's 2 divided by 2 is 1, so that goes away. So here it is. I put a half, and if I factor that out, I'm going to have e to the -2 plus 2 e to the 0 plus 2 e squared plus e to the 4th. And now that's what I'm going to look for, guys. So there we go. Ooh, that was tough, but we can do this, guys. All right. Let's see if we can continue. The function f is continuous on the closed interval 1 to 7 and of the values that are given in the table below. Perfect. Using the subintervals 1 to 4, remember these are your heights, 4 to 6 and 6 to 7. What is the trapezoid approximation of this guy? If it helps to draw a graph, draw a graph. These are your heights, guys. If it helps, 110, I'm going to say that's 110 there. And then for 430, I'm going to say that's 430. And then 640, I'm going to say that's 640. And then 720. If it helps, draw a graph. Not to scale. Those are my 3 trapezoids I want. You can see the heights are not the same. So this time you are forced to do each trapezoid by itself, guys. First trapezoid. Here's my first one, second one, third one. First trapezoid, the height is 3. Does everyone agree that the height is 3 of that trapezoid? Okay, perfect. Then what am I going to use for the base? The base 1 is going to be 10. The base 2 is going to be 30. And I divide by 2. Plus the second trapezoid between 4 and 6, that means that height is going to be 2. The first base is going to be 30. The second base is going to be 40. And I'm dividing by 2. Plus the third trapezoid, the height's going to be 1. First base 40. Second base 20. And I'm dividing by 2. And there it is, guys. And then I just use my calculator on this. I would just use my calculator. 30 plus 10 is 40. 40 divided by 2 is 20. So 20 times 3 is 60. Plus 40, 50, 50, 70. Plus 40 plus 20 is 60. Divided by 2 is 30. And let's add them all up. 60 and 30, 60, 70, 80, 90, plus 70, 160. I hope I added those correctly. And I'm going to give myself a happy face. Yeah. Are we okay so far, guys? Okay. Let's keep going. These are just notes. It's a quick review for you guys. Let's see what it says. If a function f of x is strictly increasing from a to b, and you do an LRAM with equal subdivisions, LRAM will produce an underestimate to the actual value. I don't know. Let's find out. Strictly increasing from a to b, and it doesn't tell me anything about concavity. So I feel like I should have written better notes here. So here's a to b, and I'm just going to do 2 rectangles. They want LRAM. So here's my 2 rectangles, LRAM. It definitely gives me another estimate for that one. Let me do another curve, and let me do it concave down and see if it's the same. A and B, and right in the middle, and LRAM. Yep, it does an underestimate. Check mark. Yay. If a function f of x is strictly increasing from a to b, and you do an RRAM with equal subdivisions, RRAM will produce an overestimate. Okay, well, let's do a sketch. Again, same type of sketch. Here's A, here's B. I'm drawing 2 rectangles, so split in the middle. RRAM, RRAM. Yep. Let's see if it does the same thing for concave down. And strictly increasing. Let me do a better job of that. Strictly increasing. That's A, that's B, and right smack in the middle, and RRAM again, and RRAM again. Yep, overestimate. There's more rectangle than the curve. Last one. It says if a function f of x is strictly decreasing. Okay, so now I'm decreasing. And you do an ORAM with equal subdivisions, ORAM will produce an overestimate. All right, decreasing, concave up. A, B, smack in the middle. And let's see, LRAM. Yep, overestimate. Let's do concave down, decreasing. A, B, right smack in the middle. And we're doing LRAM. Yep, overestimate both. Good job. Finally, if a function is decreasing and we do RRAM, it says that it will do an underestimate. And sorry that I changed up the color on you guys. A, B, smack in the middle. And we're doing what? RRAM? RRAM. Yeah. RRAM will produce an underestimate. And same thing if I do concave down. Concave down. A, B, smack in the middle. And sorry that my graph sucks, guys. Not perfect horizontal there. Yeah, underestimate. Happy faces everywhere. Those are just reviews. With trapezoids, I don't think it matters as much as it does for these type of graphs. For trapezoids, I think it matters more about concavity, guys. So think about the concavity of a graph. So look, this is, I guess I should have written about trapezoids. If I have a graph that's concave up and you do a trapezoid, so here's me zooming in on the trapezoid. Point here, point here. Notice that that trapezoid is a little above the curve. But if I have a graph that is increasing but concave down, so here it is, a graph increasing concave down. And again, I'm sorry for the color choices. Point here, point here. Notice that that trapezoid is slightly below the curve. Do you guys notice that, guys? So for trapezoids, what matters? Concavity. For LRAM and RRAM, what matters is the function increasing or decreasing. So make sure you hold on to that in your head. Okay. Let's continue. This is from a real AP exam. It's from the 2006. It's a free response question, so I can share it with YouTube. Every free response question is available to be shared. 2006 exam B, form B, question 6. So that means no calculator. And let's see if we can do this. So they give me time, velocity in feet per second, time in second, and acceleration in feet per second, or feet per second squared. A car travels on a straight track. During the time interval 0 to 60 seconds, the car's velocity v measured in feet per second and acceleration a measured in feet per second are continuous functions. Okay. The table above shows selected values of these functions. Perfect. Using appropriate units, explain the meaning of absolute value of v of t dt in terms of the car's motion. Okay, before we get started, I hope that you guys remember that the absolute value of velocity, just by itself, is speed. So, if you find the area under a speed curve, what are you finding?
Displacement.
Okay, be careful. Displacement is for velocity, because displacement is a vector. Speed is a scalar. So what is the scalar version of quote unquote displacement? They're not the same, by the way, but it's similar. They're similar. It also starts with the letter D.
Distance.
Distance. It's a distance, guys. Now don't confuse distance with displacement. They mean different things. But yeah, this means a distance traveled. So letter A, I'm going to say, using appropriate units to explain the meaning of the car's motion, I'm going to say integral 30 to 60 of v of t dt is the distance the car travels from t equals 30 to t equals 60 seconds. Or you can say during the interval. Maybe this is not the best English. The distance the car travels during the interval t equals 30 to t equals 60 seconds. That's probably better English there, guys. And there it is. Do not write a paragraph. You're not looking to write a paragraph. Now we got to calculate this. You guys ready? Did they tell us how to use it? It says trapezoid. Okay, trapezoid distance. Let's figure it out. So the first trapezoid, and I'm using this right here. That's my t-axis. The first trapezoid has a height of 15. So here we go. 30 to 60 of v of t dt is equal to, I'm just going to write equal to. It doesn't matter for AB students. It's for BC students it does. Is equal to, the height of my first trapezoid is 15. Parentheses. The base of the first trapezoid, we're taking absolute value, so don't write the negative in there. You're going to write 20 plus 30. Oh, wait, hold on, guys. I already started wrong. Why did I start wrong? I was going too fast. During what time do they want me to find the distance traveled?
30 to 60.
And where did I start?
0.
So am I starting correct? No, you're not. Here we go. Let's start it again. They want 3 trapezoids. So let's see, 30 to 35, okay, that's 1. 35 to 50, that's 2. 50 to 60, that's 3. There it is. Those are my 3 trapezoids. So we start at 30. So the height between 30 and 35, that height is 5. So I write 5. My first base is 14. Plus the second base of that first trapezoid is 10. Divide by 2. You have no calculator, by the way. Plus, now here comes the second trapezoid. I'm going to color code it, guys, for you guys. The height between 35 and 50, that is 15. And then I'm going to write 10 plus 0 divided by 2 plus, and then for the last one, I'm going to use black. The difference between 50 and 60, that is 10. That's my height. And then I'm going to say 0 plus 10 divided by 2. All right, guys, I'm going to tell you a secret. Well, it's not a secret. A whole bunch of people know. But I'm going to tell you guys something that it's going to drive professors crazy. But if you are unsure, I want you guys to pass this AP exam. So if you are unsure, I'm going to tell you a secret. This here is considered your answer, and you do not have to simplify. Does everything have a number? Are there any variables or letters or anything? So that right there is considered an answer. And if you wanted to, you could leave it alone right there, and the professor, well, the ones that are grading on the AP exam, they are forced to give you credit. So if you are one of those students that makes mistakes all the time, leave it alone right there. Now, because I want to do, like, I like to figure stuff out and I like to simplify, I'm going to recommend you simplify if you feel confident. But if you do not feel confident, do not simplify. On my exams, for now, simplify. Okay. When we start talking about the mock exam 1, we'll talk about how you're going to leave it. Equals. All right, let's find out, guys. Let's see if we can do this without a calculator. 14 plus 10 is 24. 24 divided by 2 is 12. 12 times 5? I think that's 60. Is it? Yeah. 10 plus 0 is 10. 10 divided by 2 is 5. 15 times 5, let's see, 15, 30, 60, I think that's 75. Let me know if I make mistakes, because I make mistakes all the time. 10 divided by 2 is 5. 5 times 10 is 50. You can also leave it like that. I got to put units, of course, right? What was this? Feet. Put units, feet. And let's see what this is. 60 plus 50, that is 110 plus 75, 185 feet. I hope I didn't make any mistakes. I think we are good. In a little bit, I'll find out, guys. Someone do me a favor and Google that, and we'll share the screen. All right, let's continue. Ooh, I love this one. Let's see if you guys can figure this out. Using appropriate units, explain the meaning from 0 to 30 of A of TDT in terms of the card's motion. Find the exact value. Okay, oh, they're testing to see if you know what that means. What does it mean? So let me draw, I'm not drawing that graph, guys. I'm just drawing a sketch. I'm gonna say this is A of T in feet per second squared, and I'm just drawing something, and this is in seconds. And I'm gonna say A to B. If I find that area, what does it mean? No yawning. What does it mean to find area under a velocity curve? What are my units? Oh man, guys. I want you guys to visualize, to explore. What are you thinking about? Hopefully you're not thinking about puppies or kittens. Hopefully you're thinking about this right here. What do you think, Mazuka?
Well, I know that if you multiply feet per second squared times seconds, you're left with feet per second.
Okay.
Like,
So that's definitely a unit of motion of like velocity or something. So here comes the big question, the big deal. Will the area under an acceleration curve I'm going to give you two options and you guys tell me which one's the more correct. Will it give me option A, my velocity? Or will it give me option B, how much my velocity has changed? What do you guys think? Area under an acceleration curve tells you how much velocity has changed. Good job. Write that down, guys, for notes. I'm going to give you guys time. I'm going to tell you what to write. Area under acceleration curve tells you how much velocity has changed. Area under acceleration curve tells you how much velocity has changed. And then in parentheses, write, it does not give you the velocity. Area under acceleration curve tells you how much the velocity has changed. In parentheses, write, it does not give you the velocity. Unless your velocity started at 0. But let's see if ours started at 0. Nope, it did not. It did not start at 0. The velocity started at -20. Okay, let's find it. Okay, oh, I just got the goosebumps. Okay, so let me first write this. 0 to 30 AFT dt will give us how much the velocity has changed. And you got to give the intervals, guys, within the interval t equals 0 to t equals 30 seconds. Okay. Now let's see if we can calculate this exact. What's the antiderivative of acceleration? You can say it. It's fine. What's antiderivative of acceleration, guys?
Velocity?
Yeah. So look, write v of t, do a little bracket, put 0, and put 30. That's what we just did a little while ago. What does this mean? We're going to do upper minus lower. V of 30 minus V of 0. Do I know what V of 30 is? Yeah, I should. I have it in a table up here. There it is. V of 30 is -14, guys. Do I know what V of 0 is? Yeah, it's -20. So you're going to write equals. And maybe we're not ready for this type of free response question, so we won't put something this hard. -14 minus -20. So my, let's see, plus, so it's going to be 6 feet per second is how much my velocity has changed between t equals 0 and t equals 30. So they might want us to write a sentence with this included. So maybe my sentence is not the best because they want to know how much it has changed. All right, last question. And then we'll get one of you to Google this question for us. Between 0 and 60, must there be a time t when the velocity is -5? Justify your answer. Okay, well, let's look at the table. It's a continuous function. Oh, yeah, easily. Is the velocity ever -5? Yes. Somewhere between what and what?
35 and 50.
Somewhere between t equals 35 and t equals 50 because, is there a theorem or is there a rule? Do you remember the name of it?
MBT?
Not MBT, not mean value theorem. There's another one. It starts with the letter I.
Intermediate.
Yeah, intermediate value theorem, guys. So I would say yes, comma, since velocity is continuous, is a continuous function, And then I would write comma. And then I would write v of 35 equals negative 10. And then I would write and v of 50, was it 50? Yeah. V of 50 equals 0. And then I would put another comma. Hence, by IVT, comma, somewhere or sometime between, I guess you don't have to be that specific, but I'm going to go ahead. Sometime for t less than 35 and less than equal to, I'm going to actually erase the equal sign, somewhere between 35 and 50. Velocity must be negative 5 feet per second. There it is, full credit. Sorry I didn't give you guys enough space there. All right. Someone do me a favor, open up a tab and Google scoring guidelines. AP Calculus 2006 Form B. AP Calculus AB 2006 Form B. And then go all the way to question 6 and share your screen with us. So let me open up security, share screen. And it doesn't matter, anyone, guys. Oh, this one had 4 parts, guys. Let's see, what part did I not ask? Oh, I didn't ask letter D, but we could have done it because we know mean value theorem. Oh, I hate myself. Okay, next time. Letter A. Look how many points letter A was. It was worth 2 points. And look what they give you. Is the distance in feet that the car travels from t equals 30 seconds to t equals 60 seconds. Oh, I don't know if I put that, it's the distance in feet. I hope I did. And did we get 185? Yeah, we did. There it is. We got the full credit. Letter B is the car's change in velocity in feet per second from t equals 0 to t equals 30 seconds. And we got 6 feet per second. There it is. We got full credit, guys. Letter C. Yes. Since v of 30, oh, I like that one better. Since v of 35 is negative 10 and v of 50 is 0, negative 5 is between negative 10 and 0. Oh, I love it. The IVT guarantees a t between 35 and 50 so that v of t equals negative 5. They didn't mention that velocity is continuous. I like my explanation better, but that's fine. They didn't. I didn't put letter D in there, guys. I wish I would have because we know how to do it, but too bad we didn't do it. So okay, thank you, Ms. Gonzalez, for sharing that with us.